Hi everyone, this is Joe from Adult Education Center on Main Street in Winnipeg, and I'm here with another homemade video, and this is based on last night's class. A couple of you were absent and had issues to deal with, and that's just the way it goes as adult students. So I just want to take a few minutes and tell you what we talked about. We are in the big topic of mechanics, which has two smaller topics, kinematics and dynamics. And those words all sound kind of strange, I suppose. Kinematics is the study of motion, how fast, how far, how much you're accelerating, all that sort of thing over a period of time. And dynamics is the study of why things move, such as forces and all that kind of thing. And then we'll mix them all together at the end. So we're talking about kinematics right now, and there are going to be three main graphs that I want to teach you about. And the first one is going to be called a position versus time graph. And I've prepared one for you here right now. Notice the numbers on there are very simple. We have, oops, I gotta watch where I turn my head. So we have the maximum position is 4 meters right there. So we have position on the y-axis. We have time on the x-axis. And remember, time is usually measured in seconds as far as physics is concerned. And so here we have a graph, and you'll notice that there are 1, 2, 3, 4 intervals. Now in this graph, there are 4 intervals. On another type of graph, you would consider that as 5 intervals, but that'll be coming up next week. Okay, so what can we say about this graph? First of all, we've got a title. It's position versus time, and whenever you're doing graphing questions, you always have to look at the title. The other two, by the way, are velocity versus time, and the last one is acceleration versus time. So I want to be able to give you one of the three and then have you create one of the other two or both. And so that's what we're doing now. We're going to start with the position time graph. We're going to study what the slope of a position time graph is and what it means. And notice up here I have the positive direction is going upwards. I've defined the positive direction as upwards. So the 0 point here, that will be our starting point in time, and it'll be our starting point in space, I guess. We're on one dimension, we're only going back and forth. So this is the positive direction. Obviously, this would be the negative direction. We can learn all sorts of things from this graph. First of all, you'll notice that this first segment here, we call it the interval of 0 to 1 second. I'm even going to mark on my graph. That's the first interval. The second interval is from 1 to 2 seconds. The third interval is from 2 to 4 seconds. Let's see here. And then the fourth interval is from 4 to 5 seconds. Sorry, got myself a little bit confused there for a second. So what's happening in these different sections? Well, we have a person or an object or a car or a particle or whatever it is that's moving. It's moving from the starting point. It's going to go in the positive direction. It's going to travel 4 meters at a constant speed or velocity, and it's going to go that far in 1 second. So in a matter of 1 second, that particle moves 4 meters. After it goes to the 4 meter mark, it turns around and it comes back to the 2 meter mark, and it takes 1 second to do that. At the 2 second time, it seems to stop. It doesn't move anywhere in any direction. It just stays at rest, and that's why we get this horizontal line where the y-axis or the position is not changing. And then in the final interval from 4 to 5 seconds, we have the object going from a positive 2 through the origin. So at 4.5 seconds, it's back at the origin, and then it keeps going in that direction. So now it's in the negative direction relative to the starting point. So you can see that this slope is positive. This slope is negative, as is this slope. This slope is 0, which means no movement. So when the slope is positive, you're moving in the positive direction. And I may define, and I should look at the camera, I may define what the positive direction is. I might say, let the positive direction be east. So that is the basics of that. Now you'll remember, I'm going to do you know me by now. I say I'm going to do something and I end up doing totally different. But I want you to recall the formula for slope. The formula for slope was y2 minus y1. Whoops. Let's go like that. Over x2 minus x1. Now, the thing about this graph that we're looking at is that it's very simple. The numbers are very simple. You don't need a calculator. That's why I made the numbers so simple. And at this time, I just want to thank the guys from a website called Physics A, EH, the Canadian saying. I learned this basically by watching their videos, and so thanks to those guys. I don't even know their names, but anyway, I'll leave it at that. I just wanted to give them credit. So we could use the formula y2 minus y1 over x2 minus x1, but we don't have to because they're simple enough. So what is the slope of the first interval? Well, it looks like it's raising, it's going up 4. So the rise is 4. I'm going to put this over here. Rise over run. It's rising 4. And what was the run? It was 1. So the slope of interval 1, we say slope, for some reason we were given this letter, little letter m. Oh, can't see it anymore. There we are. That means slope. Whoever invented that, not sure, but anyway, that's what it is. The slope of, we'll call this interval A. The slope of A, let's just do it logically, okay? The slope of A is equal to 4 over 1, which is equal to just plain ordinary 4. Okay, the next thing I want to explain is for what. 4 is part of it. But there's something about the slope of a position time graph, and this is super important. There's something about the slope of a position time graph that you can logically determine. So back here to rise over run. Okay, what is rising? Well, the position is changing, isn't it? Over time, the position is changing. And what are the units of position? Meters. Okay, so here's another M. Wow, we got all these M's going on these days. M, the meters are changing. Okay, that's the rise. That's the meters. What is the X value here? It's 1, but 1 second. So we have meters divided by seconds. And so the conclusion is that the slope of a position time graph is meters per second. And that's known as velocity. And I'm going to leave it at that for now, but I want you to make sure that you have this graph drawn in. I have another one that's just underneath this paper here that we're going to talk about and talk about the storylines. I'm losing my voice again. Okay, take care. That's it for this video.